This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and like many people who listen to this podcast, I work in teacher preparation. And during teacher preparation and working with prospective teachers, we spend a lot of time thinking together about mathematics education, and I get to talk to them and work on particular skills and practices for teaching mathematics. But then there's this moment, and for me it's happening right now, as the undergraduates graduate from our teacher preparation program, and they head off into their first few years of teaching. And myself and many of my colleagues, we have this big question of what does their teaching end up looking like once they get out in those classrooms and they get into their first few years of teaching? Are they still carrying forward those ideas that we talked about and dug into in our preparation programs? Are they putting into action those teaching skills and practices that we worked on? So that big question is going to be one of our topics of discussion today, and I have two wonderful guests with me. Amanda Jansen, who's a professor, newly minted full professor of mathematics education at the School of Education as of next academic year anyway. Mandy, thanks so much for being here.
Thanks for having me.
And also from the University of Delaware is Dawn Berk, who's an assistant professor in the Department of Mathematical Sciences and who is the director of the Mathematical Sciences Learning Laboratory. Dawn, thanks so much for joining us as well.
Thanks.
We are going to be talking about their article that is coming this summer in the Harvard Educational Review Journal, and that article is entitled Investigating Alignment Between Elementary Mathematics Teacher Education and Graduates' Teaching of Mathematics for Conceptual Understanding. But I always like to pause before we get to that topic that I really want to dig into, but I'd like to just get some backgrounds on all of my guests. So I'm going to start with you, Dawn. Where was it that you did your graduate studies, and what was the focus of your dissertation?
Sure. I earned my PhD in mathematics education from the University of New Hampshire. I worked with Karen Graham and Joan Freeney-Mundy. And I did my work. I'd been a research assistant on the writing of the NCTM Principles and Standards for School Mathematics. And I got really interested in how teachers might take up that new standards document, how they might interpret it if they were given a chance, an opportunity to sit down and read it carefully with colleagues. And so that's what I did my dissertation work around. I basically designed a professional development study and got a group of middle school math teachers together. And we spent a year reading the standards together and me tracking how they were making sense of it and taking up the recommendations.
Mm-hmm. And Joan Freeney-Mundy, I actually got the chance to work with her slightly while she was at Michigan State University. And speaking of Michigan State, Mandy, you've been on the podcast before, back in episode 1205, at the very, very beginning of this podcast. But I wanted to give you a chance to shout out to your great graduate school as well.
Right, as is your great graduate school. So, right, I went to Michigan State University for my PhD in educational psychology, and I worked with Jack Smith. And the story that Dawn just told, you might find to be interesting. Dawn actually did that professional development at Michigan State. Joan Freeney-Mundy moved there, but Dawn moved with her. Isn't that right, Dawn?
Yep, and that's how we got to know each other.
Oh, wow.
So Dawn and I met back then, and so that's where the connection began.
Well, let's dig into this article that's coming this summer in Harvard Educational Review. So this one is about investigating the alignment between the elementary math teacher education and then the graduates of that program and how they teach for mathematics for conceptual understanding. So what was the origin of this study? How did it come about? And then how did you two end up working together, having met at Michigan State, but working on this particular article?
So the paper that we're going to talk about today is part of a larger study that was funded in 2009 by the National Science Foundation. We had put in a proposal to conduct a longitudinal study trying to better understand and investigate the effects of math teacher preparation on teachers' knowledge, skills, teaching practices, and ultimately student learning. That proposal, that project really built on 10 years of previous work at UD, where we had spent a great deal of time and effort as a group of faculty and doctoral students, completely redesigning our teacher preparation program. We were dissatisfied with it, and so we really started from the ground up, again with NSF funding. We spent 10 years doing that and had collected a lot of empirical data indicating that as our students moved through the program, they were achieving the learning goals that we had set for them, and we were getting more and more effective at helping them do that. And so the next natural question for us was, what happens when they graduate and start teaching? do they retain and apply the knowledge and skills we hope that we taught them in the program when they begin teaching? This piece is part of a larger 5-year longitudinal study where we followed 2 cohorts of graduates from our math teacher preparation program out into their first 3 to 4 years of teaching.
And so it's important to note, so Dawn was the principal investigator of this grant, and there were many different studies going on, and I was particularly involved with this one that's coming out in this paper, but the data sources were a range of different pieces of evidence to think about. Some of the data sources were very close to what they learned in teacher preparation, so there another study that's come out of this grant are about the development of their mathematics knowledge for teaching, and they're taking tests that look closer to what they did when they were in our math content courses. Another project that was under this grant were how our graduates analyze classroom video. And Jim Hebert and Dawn and Emily Miller have a paper that's I think it's in press and out in Elementary School Journal, right, Dawn?
Yes.
And then Ann Morris and Jim Hebert worked together on analysis of how our graduates wrote lesson plans. And that paper is online and available in AERJ. And so the lesson plans then, that's getting closer to their actual practice. And now this study is going in and observing how they taught. So there are a range of different lenses that we use to think about how we could try to find traces, if any, from teacher preparation on how our graduates think about and enact practice. And so my interest was really connected to the pedagogy because I have been teaching more methods courses than content courses for teachers. I taught some of the content courses for teachers as well, but I've been really invested in the pedagogy side. So I was really interested in the opportunity to observe some of our graduates teach.
Yeah, I think that would be really fascinating to do. And before we dig into these particular teachers and their practice in the classroom, I want to step back to the broader conversation because there is a lot of discussion, both policy, research communities, practice-based communities, that are talking about the link between teacher preparation and then the actual practice that teachers carry out in their classrooms. So I just want to get on the same page as the two of you. How would you describe the bigger conversations that are happening right now about that link?
I think one thing we were sensitive to was increasing pressure over the years, increasing accountability calls for, can you document that your teacher preparation program matters, that it makes a difference? Do we have any evidence, any data that indicates that the work we're doing in teacher preparation programs has any impact when teachers graduate? And I think the existence of these alternative programs and how successful they've been have been in part because we haven't done a great job as a field of really collecting a solid body of empirical data to document that teacher preparation can matter and can make a difference. I think we were very sensitive to that there are more and more pressure. State legislatures are pushing teacher education programs to document that what they do makes a difference. And so we wanted to be a part of that conversation.
And just to clarify, when you say the success of the alternative routes, you mean like the success in them recruiting people towards their routes?
Right.
Yeah.
And
okay.
that they continue to exist today.
Mm-hmm.
And I think it's interesting to know, as we wrote in the paper, many folks, when we're studying the impact of teacher education, they get close to how do teachers think, impact on teachers' beliefs, impact on teachers' knowledge, and then there's a push and a call to show impact on student learning. Mm-hmm. But it's a really important link in that chain to try to see how can we understand how teacher education affects how teachers teach before we jump as quickly into studying the impact of teacher education on students' learning. Of course, we want to know that, but that teaching seems to be an important thing to make sense out of too. And we learned through doing this project why that's actually a pretty hard phenomenon to investigate and document. In mathematics education, there aren't very many examples of this where we have seen graduates from teacher education programs teach. In the research literature, Hilda Borko and her colleagues have some of the most outstanding examples of research looking at the teaching of teachers from teacher education. So other than that, I mean, I think that's one thing that we learned from this study is why this is difficult work to do. Mm-hmm. And so we can get into that at some point.
I think that one part of that's probably challenging is narrowing the focus to something that you can actually communicate in one article. And so one thing that you did from this larger study is you focused specifically on 6 particular participants, 6 teachers that you could trace in this article. And then you narrowed down all the complexity of mathematics teaching. And I was just talking to Denise Spangler on the podcast about how complex that is to try to tackle intellectually. But you narrowed in on 4 particular teaching practices. So I was wondering if you could just talk us through your process of thinking to get down to that 4 teaching practices and the 6 participants that are the emphasis of this article.
It probably makes sense to talk about how we chose the 6 participants first, because that's actually one of the challenges in doing this work. And then I'm happy to talk about the teaching practices in Dawn as well. So I think this is really challenging to follow graduates of an elementary teacher education program logistically. One reason is if we're preparing them to teach so many grades, then any job that they could get could be in one of these grades, whether it's from kindergarten to the highest grade that they could be certified to teach. So that's a wide range of grades. So that's one issue. In secondary, the grade band might be a little smaller. It depends how the program's structured. Our program adds some additional logistical challenges because our graduates are also getting certified in a second area. They're either getting a special education certification in addition with elementary ed, or they're getting a certification in a middle school content area. So we could contact them and they could say, yeah, you could come observe me teach, but I'm teaching middle school science.
Yeah.
So they might not actually teach the content that we're looking to observe. And a large majority of our students are from outside the region and they want to go back home to teach. So if we need to drive to observe them, we had to set a driving radius. So those are some logistical pieces. But essentially, we surveyed all of the possible candidates that we could observe, which are all the graduates from our program. We contacted them and asked, are you teaching? Maybe they don't have a teaching job that year because they chose to be in a full-time master's program or something. Mm-hmm. Where are you teaching? What grades are you teaching? Are you teaching any of these 4 topics? Our study focused on 3 topics that we prepared them in depth, developed in our program, and 1 topic that we did not develop in our program. And they needed to teach at least one of those 3 topics plus the contrasting topic. Mm-hmm. So you could see these range of factors. We needed to be able to drive to them, and we needed to be able to see them teaching some content that we were planning to investigate deeply. Mm-hmm. And so based on that, narrowing ended up with a subset, and then through communication factors and getting permission from their administration and so forth.
Another complicating factor was, of course, they had to volunteer to be observed in their very first year of teaching by the faculty who had just prepared them, which for some students or graduates could be a little intimidating. So, yeah, there were a lot of variables, a lot of factors that really limited how many folks were available for us to work with.
I think that makes sense, and practically speaking, that's what happens a lot in research like this, where you're going into schools and people inviting you in, that you do have to, basically go down to something that's feasible, and yet here you can still look across the 6 and draw some meaningful conclusions from them. But I also want to give you a chance to speak about those 4 teaching practices and why you chose to focus on those instead of many other things that are part of the job of being a math teacher.
Right. So you could imagine that it's both an inductive and deductive process to identify those teaching practices. Inductively, we were, of course, aware of a range of teaching practices described in the literature for promoting teaching math for conceptual understanding. So obviously our analysis was informed by prior research and theory. But deductively, we also then considered, what were we doing as instructors in the mathematics content courses for teachers to promote learning math for conceptual understanding? What instructional practices were we using? And could we see any echoes of those practices when we visited the graduates' classrooms? And so it surprised us to some degree that when we went into some of their classrooms, when they were teaching our target topics, we saw them literally using some of the same practices we used, down to we used fraction strips to talk about subtraction of fractions and division of fractions. And we saw them with fraction strips or similar visual representations. We heard them use language that very much felt like it echoed language that we used, such as when talking about the numerator and the denominator, with the numerator being the number of pieces and the denominator being the size of a piece. So we saw some echoes. And so this process of being able to recognize aspects of teaching that really felt like they resonated with what we were trying to promote helped us narrow down practices to look at more closely in the data.
And so that led you to the 4 practices of using mathematical language to support sense making, employing visual representations, for example, like fraction strips or diagrams that you can draw, pressing for explanations, and then using story problems. So any other comments on how those 4 ended up being the set that you focused on?
So the 4 practices that we focused on in the article are actually instructional practices that we enact consistently in our content and methods courses in the program. So earlier I talked about how we spent the first 10 years before we started doing this longitudinal work revamping, redesigning our program, and a key part of that work was collaboratively developing shared lesson plans for each class session of each of the 3 math content courses that our students take. And so after 10 years of work on that, we really have a pretty consistent, coherent program in the sense that no matter what section of a content course a student might take in a given semester and with a different instructor, we're pretty confident that they're getting very similar learning opportunities. They're all working on the same instructional tasks, and we're all modeling these practices in our classroom. So the use of story problems is a common thread across our courses. We're constantly pushing them to write their own story problems, or we're posing story problems for them to diagram and make sense of and write number sentences for. We're constantly pushing on language and pressing them to explain their thinking. So I think we had hypotheses going in that these were some common features we might see in their own teaching because we had consistently modeled them across the 3 courses, the 3 content courses, and those shared lesson plans helped us do that in a way consistently, regardless of who was teaching the course in a given semester.
Mm-hmm. I'm speaking with Mandy Jansen and Dawn Berk from the University of Delaware about their article that's coming out soon in the Harvard Educational Review. I'm going to refer listeners to that article. It'll be coming out very soon, and they can find the details of your methodological approach. But just here in brief, I wondered if you could just tell us the data that you had and then how you approached the data, but only going to give you a few moments to describe that so that we can get into those results that you found.
So the teachers knew that we were coming, right? So we let them know ahead of time, and we scheduled a date to come to observe. And before we came out, we let them know we are looking for a lesson where you're teaching so students understand conceptually. We wanted to give them the best chance possible to do this because we're sort of looking for an existence proof if it's possible. So send us your lesson plans with your learning goal in it, and send us any handouts that the students would receive ahead of time. So we had that ahead of time to prepare for the observation and gave us some orientation to what to expect. When we were there, we didn't video record, we audio recorded the lesson, and we took photographs of anything that was made visible to the class as a whole. And there were 2 researchers there for every observation to handle that process. And then afterward, we briefly interviewed the teachers about how the lesson went and a few other questions. The interviews, we narrowed down our analysis for this paper about what the teachers reported, about what they used from the undergraduate coursework in their teaching, what they valued about the coursework. And then in the audio and photographs, we took many different passes through the data, and as a team, myself, Dawn, and our co-author, Erin Meikle, we analyzed together each lesson and instances of when we thought were moments where conceptual understanding had the opportunity to be developed in the lesson, named and labeled those practices. And we spent many meetings on each lesson to come to a shared understanding of those findings.
Mm-hmm. And how many times did you visit each of the 6 teachers?
We visited each teacher twice each year. So this paper is about the data from year 1. And so we visited each of these 6-year teachers once for one of our 3 target topics, and then another time for our control topic of the mean.
And so you've alluded to the target topics that were covered in your program, and then this control topic, which I'm guessing is one that was not covered in your program. But is there anything else we need to know about those topics before we get into your results?
I think one thing that's important to know is we picked the target topics, again, to really maximize our chances of trying to see potential effects on our graduates' practices. It's been hard for researchers to document this, and so we wanted to give ourselves the best chances possible. And so we, as part of the larger study, thought hard about what are the mathematical domains or big ideas that we spend the most time on that we feel like have the best chance of showing up in our graduates' practice. And so that's how we identified the 3 target topics. And because of the hard choices we made in redesigning the program, one of the consequences of that was that we committed ourselves to developing a few key mathematical ideas really well, and as a result, not developing other mathematical ideas at all in the program. And so as an example, the control topic that we talk about in the paper, which is finding the mean of a data set, we do not address at all in our program. And so there's a natural, kind of a nice built-in control design there that we're able to kind of capitalize on in this study.
Mm-hmm. All right, well, let's go into the classroom. So what were some of the teaching practices that you observed when you visited the classrooms of these teachers?
So if we say, for example, if we watched one of the teachers teach subtraction of fractions, we would see conversations that were about, why do we need to find a common denominator when subtracting fractions? They weren't just saying that we need to find one or showing how you need to find common denominators. Mm-hmm. They talked about how the fractions need to have pieces of the same size in order to subtract. So we saw this unpacking of the meaning underlying the procedures. And we saw the teachers asking students lots of questions about, well, why does this make sense? Why would we want to do this? And letting multiple students take time to talk about why that does make sense, and giving them time and space to process that verbally, to interact with representations, to illustrate this. And so we would see that, and then they would be perhaps with story problems showing relationships between the quantities when they were talking about these ideas, when they were teaching our target topic. So whether it's multiplication of whole numbers, whether it's subtraction of fractions, whether it was division of fractions, we saw this kind of discourse and opportunities to make sense of the ideas. But then when we got to our target topics, so mind you, we had teachers that told us they wanted to teach math for conceptual understanding. They were ready to do it. They wanted to do it the best they could. So when they went to teach the mean, they would have conversations with their students like, well, what does the mean mean? Which is similar to what they were saying about the other topics. What does this mean? And then the students would say, well, it means the average. Or the teacher would just say, it means the average. And then they would say yes, and they would move on. So they wouldn't really spend as much time unpacking the meaning behind why the algorithm makes sense, or what does mean mean in terms of central tendency. Mm-hmm. And so it looked dramatically different. So while we saw a lot of use of story problems with the mean, which makes sense because it can be set in a real world context pretty readily, mm-hmm. when the teachers would ask the students why ideas made sense, they would use the why questions, and they would press the students to talk about their thinking. But it sort of fell flat, almost like they weren't sure where to go with it.
Yeah, so I think it brings up an interesting question about what can transfer and what can't transfer. So it seemed like some kind of generic moves our graduates were trying to transfer, like this idea of pressing students, why, what does that mean? But without the underlying mm-hmm. kind of mathematical knowledge for teaching around that key mathematical idea, they weren't able to go very far with it or develop it.
So they knew how to press, but they weren't sure what they were pressing toward? Like they weren't really sure what was going to come out of that pressing.
Right.
Or even they thought that just they accepted something different. So it could be they weren't sure, or that they were just satisfied with something with less depth.
Oh. And so I'm just in my mind, I'm going through the 4 practices. The story problems, you mentioned that you could see the story problems happening in the target topics and the control topics. But a story problem itself, we don't really know what kind of conceptual understanding would be developed from it, right? Like you could have a story problem that's just executed as a procedure, or you could have a story problem that allows for rich sense-making and stuff.
Exactly.
So that one showed up in both, but maybe not to the same level of meaning or the conceptual understanding that you're looking for. We just talked about the pressing for explanations. There was also the visual representations and then the mathematical language. So how did the visual representations or the language, how did that compare when you looked at the target topics versus the control topic?
I would say they were able to really talk about why ideas made sense with the mathematical language, either they or drawing it out from their students and helping their students develop that language too, when it was in their target areas. And they didn't have much facility to do so with the control topic. And with the visual representations, it was pretty rare that we saw anything other than procedural symbolic manipulation for the mean. And we constantly saw various discrete diagrams, area diagrams, different representations for both multiplication and operations of rational numbers.
I think the use of mathematical language to support sense making and the use of visual representations, those were the two practices that we saw more frequently when our graduates were teaching the target topics. And I think thinking about after the fact, those do seem to go hand in hand, because if you're going to use visual representations effectively, you really need to know the key mathematical ideas and have language to connect what is the visual representation doing for you. Whereas, like you said before, you can use a story problem and not necessarily go deeply into the ideas. So again, I think there's this interesting kind of hypothesis forming about what's transferable and then what do you need, kind of some underlying mathematical knowledge for teaching to really kind of capitalize on these instructional moves.
I have this really vivid image of each of the classrooms. I'm thinking about, her name was Miss Gibson in the article, and she was teaching multiplication, and she wanted the students to think about multiplication as repeated addition or groups of, and she had these plastic cups, and each cup was a group, and then she put objects of the same amount in each cup, and was able to use this to illustrate repeated addition or equal groups. And she would talk about non-examples and moving an object out of one cup and into another cup, and talk about how now we no longer have equal groups, so we can't think about them as repeated addition anymore. And she flip-flopped back and forth between repeated addition and skip counting and wanted to connect those two ways of thinking about multiplication. And so I agree with you, Don. It's not the case that we just want to see the visual, but how the teachers interact with the students about the mathematics around the visual.
Mm-hmm. It seems like there's something you could do with cups and marbles or whatever it is for the mean as well, but you didn't see it in that case. Like of we have all these marbles, let's pool them together and then let's distribute them evenly, amongst everybody. But did not see that happening, for example.
We saw it rarely. So I think there is, her name in the article would be Miss Martin. So she demonstrated in front of the class really quickly stacking cubes and leveling them out to show the mean. So maybe there were 5 different columns of stacked cubes with different cubes in each stack to have different heights, and then to level them out to then show how that could be a mean. So you could gather up all the cubes, that's like adding them all up, and then redistribute them evenly into each group would be the division for the mean. But she didn't, she only leveled them out, and she only did it like really quickly. She was the only one who touched the cubes and was just like barely mentioning it. And then we had one other teacher that did a demonstration of the
balancing.
Yes, but it was pretty rare that we ever saw any sort of visual representation for the mean. And if they did, it was pretty quick.
Right, so there wasn't as much sense making around it. It was more of a, let me show you this quickly, and then we're going to go back to the calculations.
Yes. It is possible to show a visual representation for the mean, but they didn't have opportunities to make sense out of that in teacher preparation, and it was their first year, and so that was as far as they got for how to think about the mean with their students.
So Dawn was mentioning the idea of transferable kind of skills or practices, and then here thinking about what opportunities did the teachers have in their preparation program to develop some ways of approaching these topics. So I want to follow up that line of thinking to just this broad idea of how are you now thinking about the relationship between teacher preparation and then what you're seeing in the classroom? Has doing this study, has it changed the way that you think about that relationship or that link that we talked about at the very beginning of the episode?
For me, when I teach methods now, it leads me to think about when I'm engaging the undergraduates, the pre-service teachers, and thinking about discourse moves. So we can sort of think about them as a move, like ask students why. Ask them to explain their thinking. Or we can push it further and think about, well, why are we going to enact this move now in our lesson for moving the students toward the learning goal? I always worked with them on having them anticipate what their students would say and what they do about that. But it's one thing to plan it, and it's the other thing to be able to think in the moment. So because of that challenge, I've been incorporating rehearsals more into my methods courses. So then they planned their talk moves and when they would ask why and why they might press students to explain their thinking then, and they anticipated their thinking, but being able to, in the moment, engage with that and make some choices feels very different. And rehearsals have seemed to make a big difference in terms of, oh wait, I remembered I was supposed to press for more understanding there. And either I forgot, or maybe they weren't saying the right thing that led to leading that to be the right choice. And so I think those two pieces about more of the meaning and thought behind why we would use a particular move in discourse and then adding in the rehearsals has helped.
With your rehearsals, do you feel like you have to rehearse a lot of different topics, or do you feel like you are now thinking about rehearsing in a way that will show up on many different topics that they have to teach in the future?
That is an empirical question I don't have an answer to yet. But it does, I do conjecture that they don't have to be the one rehearsing to benefit from the rehearse. So we rehearse in small groups in my office, and then we rehearse in the whole class. And it seems to be that if someone's watching someone else rehearse that's not their exact topic, they are still reflecting back what they're getting out of that rehearsal for their own lesson. So I think that's worth trying to understand more deeply.
For me, I think one implication of this work has been that I've become increasingly skeptical of these recommendations and expectations about how much we can accomplish in teacher preparation. So these goals of we should prepare teachers to teach all of the Common Core state standards, for example, and be able to enact all of the practices. For me, when I think about how much work we've done on one of the target topics, and then we don't see much transfer, say, using ideas of division when they're teaching the mean, which seem directly applicable, it suggests to me that I think the thing that's been on my mind a lot these years are we need to do a better job as a field of really thinking about what are the most important learning goals we should be setting in our teacher preparation programs. What are the few things we should be focusing on, trying to get prospective teachers to achieve, because we can't teach everything. We can't teach all of the practices and all the instructional routines and all of the content. So maybe it's a little depressing, but it's been motivating too to kind of think about that. Like, how do we make our best bets about how to best spend our time, or this short amount of time we have with them?
Yeah, that's a big challenge to make those decisions. But I think there's a big upside from this study, which is that in Delaware, you have a program where you focus on certain practices and you focus on certain topics, and you were able to observe them and empirically, with the team, be able to identify them showing up in the teacher's practice. So to me, that's kind of a win. And now it leads to the next big challenge of, if what we're doing matters and it actually is, related to future teaching practice, now we have to make these hard decisions of what we focus on, which topics, which practices, and so forth.
Exactly.
But was there a little bit of joy that you were at least seeing some things showing up in the classroom?
There's a lot of joy. It's really rewarding to go. Yes, it's really rewarding to go see your former students. So I think between the group of 6, Dawn and I each had them in class, and so that was really exciting. And I was really proud to see. They were first-year teachers. I wasn't teaching mathematics as conceptually as they were my first year. So, absolutely, it was very exciting.
Yeah, no, it was exciting, and it was very salient, I think, to us, that we could see clear kind of traces of what we had done with them in the coursework and their teaching, and for myself, I wasn't sure. It's been hard for researchers to be able to do this, and so I was kind of bracing myself that we might not be able to find such effects. So yeah, it was really exciting. And it was fun to just go follow up with your students and see what they do in the classroom once they graduate. Most of us don't get a chance to do that very much.
I've been speaking with Mandy Jansen and Dawn Berk from the University of Delaware, and their article, co-written with Aaron Meikle, will be coming out very soon in Harvard Educational Review, and that is entitled Investigating Alignment Between Elementary Mathematics Teacher Education and Graduates' Teaching of Mathematics for Conceptual Understanding. Now, Mandy and Dawn, before I let you go, I have one final question that I like to ask, and I know Mandy really enjoys this question because she will chat with me about other people's answers that she's heard on the podcast. If you were not in mathematics education as a career, what can you imagine yourself doing instead? So I'm going to start with Dawn because I have not heard yet what Dawn might think on this topic.
Yes, I have a very clear answer. I know I would be, I just know. I would either be in politics or I would go back and be a lawyer. Those are both really interesting to me.
Yeah, and probably you could do both, right? You could start out in, doing some law and then
move into politics.
Merge. Yeah.
Yep.
And Mandy, if I remember correctly from episode 1205, did you say pop singer in the past?
I probably did. That sounds like something I would say, yeah.
So I'm going to give you a chance to see if you have any other ideas, if that one hasn't panned out.
Okay, I have two. One, I think travel photography would be a blast. I do travel quite a lot, and so that would be an enjoyable experience. It sounds so luxurious right now. Mm-hmm. The other, I think I would like to be a food critic. Mm-hmm. Yes.
Nice.
Because you're very critical, or because you really like all food, or?
Well, I was actually once told I would be a pretty bad food critic because I really like to eat almost everything, so everything's delicious. But I could get excellent at characterizing various ways in which the food is delicious. When I travel for conferences, when I travel for conferences, I like to be one of the people in my social group who does the research and finds out different places to go eat. Jeff Shee and I sometimes bond over our restaurant decision-making processes, so why not write about it?
Right. Well, that sounds good, and at the next conference, people can come to you for advice on where to get a good dish.
Or Jeff. He's very good at it.
All right, great. Well, Mandy and Dawn, thanks so much for taking the time to speak with us. We look forward to this article coming out.
Thanks, Sam.
Yeah, thanks so much.